Okay, this is 7th grade math 8.3. We're going to talk about slope. This is page 409 in your book. So again, I say it every time. You need to have your book open right now to page 409. Key vocabulary is slope. Slope is a non-vertical line. Vertical means straight up and down. So a non-vertical line that is the ratio of the rise to the run, and we'll talk about the rise and the run in a second, between any 2 points on the line. I'm getting this right in the book, page 409, and it's usually written rise, instead of ratio, so we'll write it this way, rise over run. And the best way to explain slope is like stairs. Here's stairs right here. Okay, and the rise part of the stairs is how far it is there. That's the rise, how far you'd have to lift your foot up. The run is how far it goes into the wall, right, or into the width of the step, I guess is a way to say it. How much room you have to put your foot down on. And then what it's supposed to do is if these were points on a line right here and we connected those like so, that would be the same. You'd step up and over, up and over, up and over, up and over, and it'd be the same all the way through. It's consistent for the line. Okay, so we'll show you some of those, and let's take a look at some. Oh, here, let me add a couple of things to this. This right here, this is going to be a coordinate grid. I'm redoing a coordinate grid. These are on the bottom of page 409 in your book. If the line rises from left to right, we say that has a positive slope. If the line falls from left to right, we say that's a negative slope. And you can think of it this way. Think of making money. If your profits are going this way, that's positive. If they're falling, that's negative. And then we also, horizontal lines in a grid, like this is a horizontal line, we would say it has a slope of 0. And vertical lines do not count. The vertical, it can't be vertical for slope. Okay, so let's find slope. Find the slope of the line by finding the ratio of the rise to the run between any 2 points of the line. So you'll notice there's a point right here and a point right here. So it's basically counting how far would you have to rise and how far would you have to run in order to get from one point to the other. Now the run part, I remember run because if you stood on the line, you could actually run across it. Okay, we don't run up like this. So that's rise, and this is run. So we always write it rise over run. So we rise 2, and we ran 4. And you should always reduce your slope. So that's the same as rising 1 and running 2. Let's try it. Rise 1, run 2. Notice we still land on the line. Rise 1, run 2, you still land on the line. Okay, so you can reduce, you should always reduce your slope. It makes it easier. Okay, so given a picture, and I also know it's positive because the line is rising. As you look at it from left to right, as you look at the line, as you look at the line across this way, the line is rising. So that means it's positive. Okay, and we ran, another way is to look at this, we rose up, which is a positive direction, and we ran to the right, and on a number line, the right is positive. Okay, so let's take a look at what they got. Okay, same thing. Now look at the second one. Hang on here, let me erase my stuff from the slide. Okay, so this one, here's our 2 points, right here and here. and we know we write rise over run. So in this case, we rise 3, but it's going down, so that's a -3, and we run still in a positive direction to the right, 3 over 3, -3 over 3, which is -1. Another way is just -1, you could write it, but let's talk about rise over run. Let's see if it works. We go down 1 over 1, down 1 over 1. And as long as you're counting out the slope, you should always land on the line. Okay, so basically what I'm doing is I'm giving you a picture, and you're counting, you pick 2 points on the line, and you count the slope, rise over run. All right, example number 2, it says, interpreting slope as a rate. The graph represents the distance traveled by a lava flow over time. To find the speed of the lava flow, find the slope of the line. Well, there's one point right there dictated, or written for us right here is 4, 6. I think the other point, since it starts down here, why don't we use 0, 0? Okay, so if we do our rise over run, and we'll put some labels to this in just a second, we are rising 1, 2, 3, 4, 5, 6 to here, and we are running 1, 2, 3. So we're rising 6, and we're running 4. That reduces to 3 over 2, and that rise is miles, and the distance is hours. Down here the time is hours. The 2, excuse me. So it goes 3 miles in 2 hours, or at that same rate it'd be 6 miles in 4 hours, but the rate or the slope would be 3 over 2, 3 miles in 2 hours. See how they do it. Rise over run. Where did they get 9? I'm not sure where they got 9 at. It's supposed to be 4. I'm looking in the book. They have that's a typo right here. This is a typo. That's supposed to be 4. And I guess they wanted it to be a unit rate, so we could have gotten that. We had 3 miles in 2 hours, so how much would that be in 1 hour? You would divide this by 2, divide 3.5. It's 1.5 miles per hour. And I suppose if they want the rate, it would be the unit rate on that one. Plot the points 3, 4, and 6, 3, and you need to use your grids, and if you don't have any, you need to come get some from me. Then find the slope of the line that passes through the points. Now, I'm going to go ahead and use their answer because I don't have any way of drawing the grid. So 3, 4 means you always start, remember when you plot points, you always start at 0, 0. The first number tells how many you move left or right, so I'm going over 3 and up 4. 1, 2, 3, 4. So there's 3, 4 right there. Over 6 and up 3, there's 6, 3 right there. So I need to count. How far do I rise and then run? So I'm just going to go from this point. Let's do this one. I rise -1 because I went down 1, and I'm running 1, 2, 3. And notice I'm counting the spaces in between. So rise over run is -1 over 3. And it doesn't matter where the negative goes. The whole thing's negative whether it's on the 1 or on the 3. It's still negative. So the slope is -1/3. What if in example 2, suppose the line starts at the origin and passes through point 3, 6. Let's go back, 3, 6. So 3, 6 would be right here over 3 and up to 6. And the origin is right there. So the line would go through these 2 points right here. Sorry, oh, terrible. Let me get rid of that, that's ugly. 3, 6, I'm not going to even draw the line. Just pretend like there's a line there, that those 2 dots are connected. So let's see how we get from one to the other. We'd rise 6 and run 3. So we'd rise 6 and run 3. So it would be 2 miles per hour. Let's see what they get. There we go. Draw the line that has a slope of -3 and passes through 2, 5. All right, so if we know the slope and we know one of the points, what you do is you plot the point. So there's our 2, 5. So you plot the point 2, 5. You go over 2 and up 5. There it is. They tell us the slope is -3. So the next thing is to write that as rise over run. So make it a fraction. So from this point, you rise -3 and you run 1. So rising -3 is going down 3, and running 1 is running to the right because it's positive, and that's where the point would be. And then you just connect those points. And there's your line. And they're doing the same thing. And then you just count it out and draw that line. Okay, so draw the line that has a slope of 1/3 and passes through 2, 5. I don't know if they give us, well, let's do that. Okay, so 2, 5. The first thing, this is the answer, but let's just go through this. Pretend like this, that this line's not there. So you go over 2 and up 5, you plot the point first. And from this point, you rise 1 and run 3. That's where that next point would go. You wouldn't have the line yet. Then you connect the line. And a ruler would make it really nice if you use a ruler to connect the lines, because you see I'm drawing without a ruler and it just doesn't turn out very well. Draw a line that has a slope of -4 and passes through -1, 3. So you plot -1, 3, which you go -1, 3 right here, plot that point. And you're going to write this as a fraction, -4 over 1. So you're going to rise -4, 1, 2, 3, 4, and run 1. So there's my 4 down here, my -4, and there's my 1. So that's why the line goes that way, and it is a negative slope. Okay, so there's two things you're doing. You're finding the slope. After I'm going to give you a graph and you count the slope, and then we give you a point, and then you have to find the slope or use the slope to finish drawing the line. So there's lots of things. Make sure you use graph paper, and make sure you use a ruler if you are drawing graphs. And I think that's it. So we'll see you next time. Ask if you have questions.